Welcome everyone. Thank you for joining us today's Minitab demo. Topic is design of experiment. I'm now Sulawati and I'm technical support specialist at Visit System. Visit System is an independent local representation for Minitab product and training in Malaysia and Singapore. Okay, before we get started, I have some housekeeping items. Okay, if you have questions during presentation, please type them into the question box in your control panel. You may send in any time throughout the presentation, but I will address them during Q&A session at the end of webinar. Or if let's say we doesn't have enough time, so I write email to you for that answer for that question. Okay, kindly ensure that you have connected to the audio via your computer speakers. For your information, this webinar will be recorded and therefore it will be set on listen only mode to avoid interruption to the audio recording. The recording will be accessible anytime later on our website www.visits.com, or you by subscribing to our YouTube channel, Minitab Malaysia and Singapore. Okay. Okay, so actually Minitab was developed in 1972. Currently we have Minitab 19, Minitab version 19, which just released in June last year. Okay, Minitab is a software package for statistical analysis for various type of analysis, like for quality, reliability, engineering, product development, business analytics, and process validation. Okay, Minitab able to use for everyone, whether statistician or non-statistician. Minitab also provide features guide you to the answer, like Minitab Assistant. Okay, in Minitab Assistant that help you choose the right tool with simplified dialogue, but come up with the detailed report to easily interpret the finding. So maybe Minitab will be your data analysis partner. Okay, so for this one is example for the various type of analysis you can provide by Minitab. Okay, for example, you want to produce analysis for the distribution or for information state, like you want to do the hypothesis testing, or you want to do the visualization like Pareto chart or bubble chart, or you want to do the quality control, like you want to produce the CPK values. Okay, or you want to do some reliability engineering, okay, or you want to do some modeling like business analytics, let's say for the time series, and many more inside Minitab 19. Okay, so I think most of you familiar with this framework. We call it DMAIC framework. D for define, M for the measure, A for the analyzing, I for improvement, and C for the control. So we try our tools inside Minitab 19 into this framework. Okay, for example, for the DNM stages, maybe you can using like Pareto chart, control chart, capability, or for the analyzing, maybe you can go for the ANOVA, for the correlation, for the regression, for the improvement, maybe you can go for the DOE, design of experiment, and then for the control chart, for the control stage, you can go for the control chart and capability. Okay, so this one is our user for Minitab. For your information, our user not limited to the manufacturing industry only, but Minitab will be used to others industry like services, finance, and academician. Okay, so our agenda today is we go for the first part, for the theory part. What is the design of experiment, or DOE, and inside there we need to know some terminology before we go further, and then maybe we have some like how to run, how to do the experiment, a design of experiment, and then we go through how to analyzing DOE using Minitab. Inside that, you need to know what is the significant factor, which one is the uh, most important level for each factor inside the problem, and then you can go for the optimization. And then if let's say we have time, I will show how to use the assistant for the design of experiment using Minitab 19. Okay, so hopefully this agenda will can answer the question like how do you want to select appropriate design, how want to ensure that you are good the right number of factor and level, and after you gathering the data or after you run the experiment, how do you want to pick the right model for your analysis part. So hopefully that you can find out the answer through this webinar. Okay, so some process in business will solve so complex. So you need a comprehensive model that help you understand how the system works. Okay, you obviously cannot get by the adjusting one factor at one time and experimenting in a disorganized way. So design of experiment, or DOE, is the ideal tools to build model in very practical, cost-effective, and flexible whenever used to improve or produce new product in the right process setting. Okay. So DOE consists of series of runs or tasks in which purposely changes are made to the input variables. Okay, so DOE helps to investigate the effect of the input or variables or output or some parameter on the output variable or something like we click response at the same time. Okay, so maybe you can use DOE to know which factor are significant effect on your response, or to identify the effect of an interaction between two variables, or you want to optimize your process performance, or you want to reduce development time for the new product, or you want to reduce variation in a process, or you want to determine the optimal setting of factor that optimize all responses, include safety and costing. Okay, so we need to know some terminologies before we go further. Okay, the first part is we call it outcome or response, or in mathematical we call it that is a Y. Our Y is the measurement you are interested in improving. And then the second one is a factor. Sometimes we call it variables, sometimes we call it parameter. It's the things you can actively change to influence the outcome. So in mathematical equation, the factor, variables, or parameter can be your X. Okay, and then is another terminology is we call it level. So level means that setting for each factor in the study. Let's say we have, for example, we have the boiling water. Okay, the simple experiment we go through. So our response is our Y can be the time of water boiling in minutes. Okay, and then the factor maybe we'll consider to know about how long the time is boiling. The first factor may be the type of pot, okay. The second factor may be electrical heat, and then the third factor maybe have a lid, okay. So for each factor inside there, you may have another term, we call it level, okay. So for example, we have two level. We call it, we have a low level and we have the high level. So for example, for the type of pot, we have a low level for glass, a high level for the metal. And then for electrical heat, maybe for the low is low, and then for the high level, we set it for the high level. And then for the lid, we have lid pot and lid on open pot. Okay, so this one is some terminology before we go further. Okay, the first is outcome or response or your why, and then you need have your factor or your variable, or sometimes we call it that one is a parameter. Okay, and then we have a label. For example, we have two level, low and high level for each factor. Okay, so this one is the terminology you need to know before we go further. Okay. Okay, so this one is some guidelines to you use DOE. Okay, the first step maybe you need to define the problem and your objective. After you know your problem and objective, you can choose it the factor and level for each study. Give basically for the previous example, I said that is the water boiling. So you want to know, your objective is you want to know the time, how long the time, okay, and then the factor is maybe your part, your electrical heat, okay, and then after you know your factor and level, you need to determine the appropriate response. So for this that case, we take the time in minutes, okay, and then after that, you know how many factor, how many level, you need to go for the experimental design here. Okay, so in DOE, we allow type of experimental design. We explore after this. After you know how many run from your experimental design, you run your design, and then after you run your experiment, you need to analyze your result. Okay, after you analyze your result, means that you now have some like modeling. Okay, what is the significant factor? So you can verify your result using conformance run, and then after that you go further make a recommendation or some like summaries. We can go for the 4 major steps. For this one is, we call it planning part. Okay, this one is for the screening part. This part is, we call it, that one is the optimization, and this part is, we call it is a verification. So some other practitioner maybe we have for planning phase of the DOE, planning, screening, optimization, and then verification. Okay. So in Minitab, we have 5 major design experiment. Okay, the first major is the screening part, which is you have a lot of factor, let's say 20 factor, you want to optimize only 5 of 2 of 3 factor from the screening part, and then you go for the factor design. In every factor, you have a level. So basic one, we starting with the 2 level, or you can more than 2, you can go for the factor design. And then after that, we have also, we call it response surface design. And then we also have the mixture design. We also have the Taguchi design. But for every experimental design in here, we have something like, for the factorial design, we have a 2-level factorial design, full factorial design, bracket, plot design. Okay, so but for this time round, we just proceed with the factorial, and we just choose the full factorial design only. Okay. So factorial design allow you to seamlessly study the effect of several factors on a process, varying the level of the factors used rather than individually. So factorial design to efficiently estimate the effect of each factor on the response. They estimate the effect of interaction between two or more factors on the response, and then test the for curvature in the response by including center point in the design. So I think for the third part is for the highest ranking. So we go for the first part and two part only. Okay. So in Minitab, exactly I go directly to in Minitab first. Okay. For this one. Once you open the launch the Minitab, so where you can get the DOE, go for the stack, go for DOE, go for the screening, Factorial, we have response surface, we have mixture, and then we have a Taguchi. Inside every major design of experiment, you can have another way like this. Okay. Okay, so for today, just only for the factorial. So inside factorial, we have a full factorial, we have fraction factorial, we have split plot design, we have a bracket Bourbon design, and then we have a general full factorial design. So every design here have our own description. For let's say for the full factorial, we have measure response at all combination. Okay, for the general full factorial, we measure response at all combination of the factor level. So this design can run a factor at to 100 level. Means that if let's say you have a 3 level, so we consider that you're using general full factorial. So let's say you just using only 2 level, so you can go for the full factorial. So every design we have a number of factors. So for example, you have a full factorial. So the number of factors for the full factorial 2 up to 15. Okay, same type for the fractional factorial. Okay, so inside fractional factorial means that fraction is half from the factorial. Okay, so for the splitting plot, bracket Bowman and general full factorial. But for this time round, I could just go for the full factorial only. Okay, so we have 5 reasons. Okay. 5 reasons why factorial design is successful. Okay, so the first part is factorial and fractional factorial design are more cost efficient. Okay, factor design estimate the interaction of each input variable with every other input variables. Okay, factorial design are orthogonal. Okay, factorial design encourage a comprehensive approach to problem solving. Okay, two-level factorial design provide an excellent foundation for a variety of follow-up experiments. So if let's say you want to learn more about this article, so you can access back to our article through this link. Okay, so but for this time I have one case study. Okay, you just leave it in this article first. Okay, we go for, focus for this problem. Okay, we have a manufacturer of packaged cake mixes must determine the recommendation baking time and temperature to print on the box. Okay, for this data collection, for scientists duplicate a full factorial design twicely. Okay, they bake all cake in a single oven in a single day, so no blocking variables is required. And then they bake the cake for 30 minutes and or 15 minutes at the temperature 3 to 5 Fahrenheit and 375 Fahrenheit. The scientists calculate moisture content by measuring the mass of the material before and after baking. So for this case, they have a 2 factor, which is a baking time and then temperature. Okay, baking time and temperature. Inside of each factor, they have a label. Let's say for the baking time, they have provide 30 minutes and 50 minutes. And then for the temperature, we have a 3 to 5 Fahrenheit and 375 Fahrenheit. So means that, and then now they choosing the full factorial design, which is now they provide 2 power of 2, means the 4 run, but they say that they do it twice. So means that 2 power of 2 equal to 4 times with the how many replication you do. So for example, this time is we have a 2. So means that now the complete run of this experiment is the 8. Okay, so never mind, I go directly to Minitab, easy to do it. Okay, so for example here, okay. For example, we have go for the stack, go to DOE, go to Factorial, and then inside Factorial, you choose create design, factor design. Okay, for information, if let's say you doesn't have any idea to know the combination for each experimental, so you can Minitab can help you by create factorial design before you run the experiment. Okay, so you choose create factorial design. Okay, inside here, dialog box, you have a 2-level factorial, 2-level factorial, 2-level factorial, and then the number of factors here. Okay, so for example, for this case, we have 2 levels. We have a factor, we have 2 factors, and then you go for the display available design. Okay, so in here, if let's say you go for the column base, this one is the number of factor. So this one is the row, means that number of run. Okay, so for example, for this case, we have 2 factor. Okay, 2 factor. So maybe you can go for the 4 run. Okay, if let's say you go, we have a 3 factor. So if let's say you go for the full, you need to go for the 8 run. Okay, so this one is they have something coding for you. Okay, we have a green color here, we have a red color, we have a yellow color, but I will explain after this here, and then go for the design. Okay, so now this one is a full factorial. It's just for you. So you need to run 4 run. Okay, and then you doesn't have center point for the per block. Center point means that if let's say you consider have a curvature or you have a quadratic modeling, okay, or we have a replicate for the corner point. So we have a 2 replication. Okay, let's say you have another factor, we call it block. So for this case, we doesn't have blocking. So you click OK, and then after that, you go for the factor. For example, here, factor A, we consider that baking time. Okay, baking time. For factor B, you consider that temperature. Okay, so baking time, we consider that is a numeric. For this case, is 30 minutes. Case is 50. For this case is 3 to 5. For this case is 375. Then you click OK. After that, you click OK. So now you get the combination for this experiment. Okay, I will do, go to stack, go to DOE, go to Factorial, you choose create factorial design. You need to choose how many factors you have, and then go for the design. Okay, and then if let's say you have replication, so you go for replication, and then you click OK. So now you get the worksheet for this experiment. So from that, we have from here, so we know now you have 2 factors. So you run 8 run, you have 1 block only. So your replication is 2. So go for this one. So means that now you have first run order, Okay, first round order means that you need to combine your baking time 30 minutes with your temperature is 375. And then if let's say here you have your measurement, also your watt, so you put down here. Okay, your Y. The first one is the first run, second run, and up to 8 run. Okay, so you get your Y here. So this one is how to create the design through the Minitab. Okay, so I go back to this one. Okay. Okay. So this one is, for example, I say that, for example, we have 6 factor, we have 2 label, which is we have 2 power of 6. 2 here, which refer for the label, 6 here is for the factors. Means that the possibility you need to run is 64 possible combinations. So for example, here is our factor, it's 6. And then let's say you take it the full factorial design. So means that you need have a 64 run without replication. Let's say you have 2 replication, 64 times with 2. Okay. So, but there are 4 design in this column. Okay, the Roman numeral refer to resolution, or we call it confounded. Okay, resolution tells you how clear you are able to see the effect of the experiment. So for this case, we have a red color here. We call it resolution 3. Okay, this one is a poor resolution. So if let's say you proceed with the 6 factorial with a 2 level, okay, with the 3 resolution, so means that you just only run for the 8 run only. Okay, so if let's say you choose the yellow color here, means that resolution 4. Okay, so you just only provide 60 run. Okay, so let's say if a green color here is the best suggestion. If let's say you have a 6 factorial, maybe you can go for the 32 or you can go for the 64 run. Okay, so depends on your preference. Okay. So from here, we know about the how many factor, how many run, okay, so how many replication. So for this case, supposed to be, we have the 2 power of 2 equal to 4 times with the 2 replication. So instead now we have a 8 replication, okay. So we have, now we already have the experimental design, okay. So we go for the analyzing factor design, okay. The same case study, okay, the same case study. We manufacture of packaged cake mix must determine the recommendation baking time and temperature to print on the box. They want to find the factor setting that result in a mean moisture content of the 26 plus minus 1%. Okay, so I go back to the Minitab. Okay, so for this one, so you imagine now we already run the experiment. So now we have our Y. So our Y here is our postural. Okay, means that before and after. So they get this Y. Okay, so how to analyze this one? Okay, so this step we want to find out, is it temperature effect to moist, and then time, is it effect to moist also. But we need to stretch again. In temperature we have a 2 level, 325 and 375, and then for the time we have 30, we have 15 minutes. Okay, so how? Go to stat, go to TOE, go to factorial design. So you go for the analyze factorial design. Okay, so for this case, is our response is moisture. Okay, and then go for the terms. So you choose up to 2. So this one is A, factor B, and the interaction between A and B. So you click OK. And then after that, you can go for the graph here. Okay, so we want to Pareto. We want to residual for the assumption of the modeling. Okay, so this one, and then click OK. After that, you click OK. Okay, now you get the result. Okay, So we can go through to the Pareto chart to see whether temperature and the time is significant or not to our problem. Okay, for this case, because this line over this line, so we consider that all this term, all this effect is significant to our problem. So you want to you go further, you can go to the ANOVA variance. Okay, for this case, you go for the model for the line up to most of this one less than 0.05. Okay, to consider that is a significant. Okay, so we can go for the one by one factor also. So for the temperature, so we go for the p value is less than 0.05. Time also less than 0.05, and then interaction between time and temperature also less than 0.05. So means that now all this term is significant to our study. Okay, but is it this model, is it fulfill the assumption? Okay, so we go for the checking assumption. Okay, for this time out, so you go for the normal probability, right? Okay, so normal probability show a straight line. Okay, a straight line means that the residual follow a normal distribution. Okay, and then the residual versus third value show the random separately, indicate a constant variance of the residual. And then the residual seems randomly scattered around the zero, okay, around the zero. So instead we accept, and then we say that this model is the best model. Okay, so let's say if you not fulfill this assumption, you need to run it again. Okay, for this case, just only one iteration. Okay, but never mind, in Minitab we have provide, let's say I go back to the stat, go DOE, go to factorial design, you analyze factorial design. Okay, you go for the stepwise. They have you give it you, let's say you choose the stepwise method. Okay, we have a method to define out the best factor in your model. Okay, so let's say you choose for the stepwise, click OK, and then click OK. Okay, for this case, the same result because the same models, we say that, and then the same residual. Okay, so let's say your model is not fit with this assumption, so you cannot accept this modeling. So you need to run it again. Okay, so in Minitab we have type to run that model. So go to back. Go to stepwise. We have step one method, we have forward information method, we have forward selection, we have backward elimination. So this one is based on your preference. Okay, so if let's say you don't want using this method, so you can go for the term, and then you can pull out one by one term in here. So you can get the best model for your analysis part. Okay. So after we know now temperature and then time is significant, but inside the temperature we have two, okay, 3 to 7 or 375 Fahrenheit. In time also we have a 30 minutes, we have a 50 minutes. So from there we need to know which one is need to put down at our box. Okay, so go to step again, go to DOE, go to factorial, go to the factorial plots. Okay, so that's one, this one, and then if let's say you click OK. So now we know the effect for each factor. So let's say you want the highest number of picture. So means that the temperature should be 27.5 maybe, the best for the temperature. And then the best time for the time is the less time, which is 30 minutes. Okay, from the factorial plot also, you can go for the interaction between temperature and the time. Okay, because we know from here, we know this one have a significant between interaction between temperature and the time. So that's why it will provide this one is the interaction. Okay. So from here, we know whether temperature is 3 to 5, and then the time is 30. But now we have our aim. Okay, we have our aim to should be the moisture content should be the 26. Means that we need to go for the optimization. Okay, so we need to go for the optimization. How to run optimization in Minitab? So go back to the stat. Okay, go back to the stat. Go to TOE, go to Factorial, and then choose Response Optimizer. Okay, choose the Response Optimizer. Okay, so for this case, we have our target is a targeting. Our target is 26. Okay, so we have the lower, we have 25, we have the upper, we have a 27, and then you click OK, and then you click OK. Okay, so now you have the RSM. So from here, you have your target 26. Okay, so your temperature should be 375, and then your time should be 3.58 minutes. Okay, so in this we have the confidence interval, 95 confidence interval for this optimization about 20 to 3.13 and then to 8.87 and then to 20.38 between 31.62. This one is the predictive interval. Okay, so from here is that our D is optimal one. So which is they suggested to get the 26 moisture, you should be using 375 temperature, and then our time should be 30.589. Okay, so this one is how the optimization running. Okay, so I think I will do again. Go to stat, go to TOE, go to Factorial, go to response optimizing. Okay, so let's say here we have our target. So you choose the target. You have a setup here, a lower and upper. Then you click OK. After that, you click OK. So you get the response optimizer for the moisture. Okay. So in TOE, you need to create your design first. Okay, design first. After you create the design, you run the experiment based on this design. After that, you need to go for analysis part. Okay, to find out the best model, which is inside there. You need to know what is the significant factor to your model. After you know significant factor, you can go for the factorial plot to know which level for each factor, and then after that you can go for the optimization. You can using the response optimization. Okay, so this one is the step how you want to do it, DOE, from the create design experiment up to analysis design experiment. Okay, so I think it's a hard topic, okay, for today webinar. Okay, so you need to remember again, we go for the start, we go to DOE, we go for the Factorial, we create factorial design to create the factorial design first, and then you go for the analyzing factorial design itself to find out the best model. After the find out the best model, you can go for the factorial plot, or you can go for the RSM, or you can go for the prediction. So because now we already have the model here is our model, our regression model. So put here only. Okay, so this one is how DOE works for you. Okay, then I go back to this one. Okay, if I go back to this one, so we go for the analyzing part, also done. We go for the find out the best model, also done. We go for the visualization to find out the best combination, okay, done. And then we go for the optimization, also done. Okay, so we have another features. Okay, we have another features is we call it a system menu. The pick appropriate statistical tools. If let's say you're using a system menu, they have a step-by-step guidance for you. So to ensure you success, you run your analysis quickly and easily, and then you can interpret your result with confidence because we provide the summary report. Okay, we provide the variation report, and then we provide the report card. Okay, so after you get that result, you can share your finding with one click only. Okay, I have another case study. I not go through for the first case study because just for the system menu, I just proceed with the screening part only. Okay, we have another case study. We have for potato chips are deep fried, creating a high amount of fat in the final product, which food science wants to reduce 9 factors may influence the percentage of the fat removal from the chip and can be grouped into 3 main categories. Is oil extraction, which is inside there we have pressure, we have temperature, and we have time. In oil separation, we have pressure again, we have temperature, we have volume of CO2, and then we have a chip, size of chip, let's say, if and chip, let's say soft, size, and the type. It means that we have 3 main categories. We have every category we have 3, so means that we have a 9 factor, which is part we want to know which factor only. Okay, so that's why we're using the screening part. Okay. So I go to that Minitab. Okay, so screening part. So go for the assistant, go to DOE. So inside DOE, you can go for the plan and create. Okay, so you can plan, create the screening design, and then or you can create the modeling design. For this case, I choose the create design. Okay, for this case, I choose the create design. Okay, so for this case, our response, and then the factor, we have a 9 factor. Okay, we have 9 factor, and then we have a 9 factor, so you can rename inside here. Okay, so for example, here is a pressure, extraction for the pressure, extraction for the temperature, extraction for the time. Okay, for the time, separation, pressure, separation temperature, separation volume, salt, and then we have size, and then we have type. Okay, for the size and type, the type is the categorical. Okay, so categorical means that the attribute. For the size, we have a small, we have a larger. For the type, we have the red, we have the black. Okay, so for the time round here, from here we have a 30, we have a 50. So you need to type in this one, 50, we have a 70. So for this case, we have 35, we have a 75. Sorry, which one is new? You need to type in one by one. Okay, 35, we have 40, we have 600, we have 800, we have 0. Okay, we have 1 here. Okay, after you are typing, and then you click OK. Now they provide the design also. Okay, and then from here we know we have 12 run. Okay, just for design. So from the extract pressure up to the type. So the first one, second, and so on. Okay, so we have already a result. You need to imagine I already run the experiment. Okay, so already run the experiment. Okay, so we have this kind of the result for this experiment. So I go to back to assistant, go to DOE, okay, go for the analyzing and interpreting. So I choose the fit screening model. Choose the screening model and then click yes. Okay, so now you get the result here. So now you get the result. Okay, so based on this result, just only two factors have significant to this study is separation pressure and the extraction pressure. So from there we have the comment here. You can conclude that we have two of the factor in your model are significant at the 0.1 level significant. But the model explain 88.98% of the variation in the fat removal. Okay, so which is the white color here is significant. Okay, so we have a screening diagnostic report and then we have the report card. Okay, so maybe go to assistant, go DOE. So you need to create a plan first. And then after you create, you run, you go for the DOE, you analyzing and interpreting that result. Okay, so you get that result, this one. So create the screening, okay, screening, and then you go for the fit screening model. Inside the create screening, they provide also like summary report. So mini run, okay, this one is the information detection, how many power of sample for your process, and then they provide the report card, and then they provide the fit screening model. But I think if let's say you want to further, I not encourage you using the assistant DOE because it's something like have a lot of the equipment inside. If let's say you're using the assistant DOE and then penetrate. Okay, because inside stat DOE Factorial, create the Factorial, for example, go for the display. So this one, a lot of we need to go for the with resolution. Okay, 3 or 4 or 5 full factorial design. So seems like this one. Okay, but if let's say you just only do the, let's say for the screening part, go for the assistant, go the DOE, plan and create, or you can go for the analyzing and interpreting because they give it you the result like this one. Okay, rather than you using this one. Okay, this first case study here. For the case study here. So you need to go for the finding the model and then finding the factorial, and then you need to go for the response optimization to do the prediction. Okay. If let's say you have any question, you can chat or email us. Okay. So I will do again. I will review again. Okay, inside DOE, we have a major design screening, factorial, response surface, we have mixture, we have a technology. Inside the factor itself, we have a lot for factorial, we have the fractional factorial, we have bracket moment, we have a split plot, okay, a lot of type of the design itself. And then we have a screening, okay, we have a response surface here, we have mixture, we have a technology. Okay, so if let's say after you already choosing your design, okay, so you go for the analyzing factorial design. So let's say for the new enhanced for Minitab 19, we include the binary response. So let's say your why now is accept or reject, yes or no. Okay, so you or you have let's say like probability. So you can go for the binary response. Or let's say your y, not only one y, you have more than one y, so you can go for the analyzing variables. After you know the best model, so you go for the prediction, or you can go for the response optimizer. Okay, I think we doesn't have enough time to go through all the Q&A session, but I will email you after this. Okay, so in summary, DOE proved to be a very effective model to identify the factor that had real effect by making them clearly emerge from the surrounding process noisy. DOE could easily be extended to the operating process. Okay, so if let's say you want to go further, okay, you want to learn more about DOE, you can join our training for the factorial design and DOE in practices. So let's say you have any question, okay, so let's say you have question, you just type at the chat box. I will review after this, okay, because we have doesn't enough time to answer that question, okay. And then if let's say you want to know our software or our training part, so you go may visit our website www.minitab or www.visits.com, or you want to contact us to sales@visits.com, or you go for the minitab@visits.com, or you can follow us to the media social like Facebook and link at the Minitab Malaysia and Singapore for Facebook and link. Or you can subscribe our YouTube channel. Okay, if let's say you want this material, you can drop your emails. I will send after this. So thank you guys.